first order differential equation is linear first order. And under the linear first order is of the form dy dx plus a certain p of x multiplied by y is equal to q of x. Dy dx plus p of xy is equal to q of x. Always linear first order is in this form. And we call something integrating factor, which is represented by a variable of r. This is called e exponent integral of p of x dx. Or this p of x coming from what? The p of x here. So always you have to find your integrating factor, and it goes by this formula. After getting your integrating factor, you take your integrating factor and multiply to the whole question. But before you find your integrating factor, you should make sure that the coefficient of this dy dx is what? 1. Meaning, s the biawunya dy dx 1. Number b will try so b will try so that in upper different side. High always 1 the coefficient of this one is 1. So after getting integrating factor r in there, then you go back to this question or the original question, multiply through by the integrating factor r. After multiply through by the integrating factor r, then you multiply the whole equation. First I multiply the whole question by what? Dx. You'll just solve it as a separation of variables. So let's solve examples here. So we'll solve the first one. We have this 3 questions, so we'll solve it. We have a x plus a dy dx minus 3y is equal to x plus a all taken in power of 3. But you should bear in mind that the definition of differential of linear first order, the formula, is say anything attached to this dy dx should supposed to be 1. So we have to clearly, I said the coefficient of this dy dx is a1. I mean I have to divide both sides by x plus a. So dividing both sides by x plus a, then I'll have my dy dx minus 3y all about x plus a is equal to x plus a our 3 all about x plus a. Rewriting this one, we will have my dy dx minus 3y x plus a is equal to this taking the power of 1. It will reduce this one to what? X plus a taking the power of 2. So here we have my equation 1 is dy dx minus 3x plus a y is equal to x plus a all squared. Let's compare this one to the original form of linear first order. So we will have something like dy dx plus p of x y is equal to what? Q of what? X. Anything attached to the y is what? P of x. So in this case, you can see that my p of x will be what? Negative 3x plus what? A. I didn't attach y. If we not attach y, here is plus, that's why I included the negative here. Right? So we'll have my p of x to be equal to negative 3 over x plus what? A. Then I'll move on to the next step. The next step says that we should find our integrating factor what? R, which goes by this formula. R is equal to e exponent integral of what? P of x dx. So I'll have my p of x is what? Negative 3 integral of 1 over x plus what? A dx. When I integrate this one, I'll get ln, because x plus a here is taking the power of 1. The 1 is the same as the 1 is 1. Anytime you have to integrate this one, then I'll get ln of x plus what? A. Then I'll have my integrating factor r to be equal to e exponent this minus 3 ln x plus what? A. Rewriting this one, I'll have something like e exponent ln x plus a taking the power of what? Negative 3. And we may cancel it. Not aka x plus a taking the power of minus 3. Therefore, my integrating factor r to be equal to 1 over x plus a taking the power of 3. So now, the next approach in linear first order is that after getting your integrating factor r, integrating factor r, go back to the original equation or the equation 1 here. Now multiply through by that integrating factor. So here, when multiply this divide the by integrating factor r, then multiply by the integrating factor r, then I'll multiply this one by what integrating factor r. So here I'll have something like 1 over x plus a taking the power of 3 dy dx minus 3y x plus a, then we multiply by the integrating factor, which is what x plus a taking the power of 3 is equal to, we have x plus a taking the power of 2. So this one will be x plus a taking the power of 3. So now let's rewrite this one. So I'll have something like 1 over x plus a taking the power of 3 dy dx minus 3y all over indices. This one is taking the power of 1. The bases are the same. You add the exponents. So we have x plus a taking the power of 4 is equal to, this is taking the power of 2, this is taking the power of 3. Then we have 1 over x plus a. The next approach or the next step in linear first order is after multiplying by your integrating factor r, just multiply the whole equation by what? Dx. So multiply this one by dx, multiply this one by dx, multiply this one by dx. So multiply this one by dx, we have 1 over x plus a taking the power of 3 dy dx dot what? Dx minus 3y x plus a taking the power of 4 multiply by what? Dx is equal to 1 over x plus a multiplied by what? Dx. This dx, everything dx, leaving 1 over x plus a taking the power of 3 dy minus 3y x plus a taking the power of 4 dx is equal to 1 over x plus a taking the power of 4 dx. I have dy dx dx here. Then we have to integrate this one, integrate this one, and integrate this one. So integrate this one, integrate this one, integrate this one. But check these two cases, or check the left hand side. The less complex one is this side. Just compare the two. The less complex one will be this one. So I'll cover this d, cut the d way. So look at it. We have this. We have 1 over x plus a taking the power of 3 dy. So that dy I know cut the d. So cut the d. So I can say y. For that y now, probably multiply this one. So we'll get something like y over x plus a taking the power of 3. Now, telling you we equal to 1 over x plus a dx. Right? So here, how to solve this with integration by parts? But here we have skipped all the steps in order to conclude at this point. That anytime you solve it, the combination of this one, we get y over x plus a taking the power of 3 to is equal to this one. So here we have done with this side. So the next thing we have to do is we have to integrate this one. This one, we have 1 over x plus a taking the power of 1, the same as the one here. So anytime I integrate this one, I'll get ln, because the one is the same as the one, I'll get ln the denominator, which is what? X plus of a. Then we'll add a certain c to this. So we'll have y over x plus a all taking the power of 3 to equal to this one. We have a second case here. This one will solve using the linear first order approach. And you should bear in mind that anytime you have to solve linear first order differential equation, you have to apply linear first order. The attaching dividing rate should always be 1. So the first thing you have to come across is just check this side. If there's anything here, try to move this one to the other side. So here we have, because we have cos x here, then I have to divide both sides by what? Cos x. Dividing both sides by cos x, then I'll have dy dx plus y sin x over what? Cos x is equal to cos squared x over what? Cos what? X. Now, can I rewrite it from my paper in here? This one is the same as dy dx plus y. Sin x over cos a is the same as well. Tan x. We have cos squared x over cos x. We overcome the theorem by this one is the same as cos x. So this cos x will cancel one cos x, leaving what? Cos x. So I will name this one my equation 1. We are done with the first step in the linear first order approach. The second step in the linear first order approach is we have to find what integrating factor r. How to find the integrating factor of r? Now let me compare this one to the original form of linear first order. We have dy dx plus p of what? X y is equal to what? Q of what? X. Anything attached to the p of x, anything attached to the y is what? To p of x. So apply this one. You know this one confirms the original form of the linear first order. We have the q of x as what? Cos x here. I have my dy dx, I have my dy dx, I have plus something that's tan xy. So I can definitely say that my p of x is what? Tan x. Now how to find integrating factor? I'll have my r to be equal to e exponent integral of what? P of what? X dx. But my p of x in this case is what? Tan x dx. Right? So here, how to integrate this one? So here, what I will do here is that I need to find out the way. I will just add this one. So I'll have integral of tan x dx. So how to integrate this one? This one is the same as integral of sin x over cos x dx. I'll let a certain variable, let's say u, to be equal to the base, that's cos x. Differentiate this one, my du will be equal to negative sin x dx. Then I'll have my integral of tan x dx to be equal to integral of sin x over my cos x. I let cos x to be equal to what? U. So I have u here. Now my dx is what? There's a negative here. Du over what? Sin x. We eventually then we'll have something like negative 1 over u du. When I integrate this one, I'll get negative ln u. But I know my u as what? Cos x. So I'll have negative ln cos x. So I have negative ln cos x. But this negative, I can apply the rule of log for ln. So this one is the same as ln cos x all taken the power of what? Negative 1. This one is the same as ln, open a bracket, 1 over cos what? X. This one is the same as ln sec x. So when I integrate tan x dx, I'll get what? Ln sec x. So now I'll come back here. So I have my integrating factor r to be equal to e exponent integral of tan x dx is the same as what? Ln sec x. So I have ln sec x. This ln will take the e here. So I have my integrating factor to be equal to sec x. So now we are able to find our integrating factor r. The next approach is that I'll come back to this equation 1. I'll multiply this one by the r, multiply this one by the r, multiply this one by the r. Then I'll have something like sec x multiplied by what? Dy dx plus y tan x multiplied by my r, which is what? Sec x is equal to what? Cos x multiplied by my r, which is what? Sec x. The next approach is that multiply both sides by what? Dx. Multiply both sides by dx. I'll have sec x dy dx dot what? Dx. Multiply this one by dx. So plus y tan x sec x dx is equal to cos x sec x dx. So now after multiplying through I multiply the whole equation by dx. I can see that this dx will cancel this dx. So I'll have sec x dy plus y tan x sec x dx is equal to cos x sec x dx. I have to y dx dx, and I have to integrate this one, integrate this one, integrate this one. So here, let's consider on the left hand side. When I say left hand side, this is equal to separating the two things. So I have this as my left hand side. I have this equal to my right hand side. So let's concentrate on my left hand side. The less complex one will be this one. So the very say, make over dv. What is left is y. I'm going to y here, I'm multiply it. So I have y sec x. Make sure you is equal to integral of what? Cos x sec x dx. So now we have this one. So what I will do here is that I have y sec x is equal to integral of I have cos x here. But you know that cos x is multiplied sec x. Or you know that sec x is the same as 1 over what? Cos x. So I have my dx here. So of course we take the cos here. So this one will cancel this one here. Then I'll have my y sec x is equal to integral of what? Dx. The coefficient of this one is 1, so this one is definitely there. So when I integrate this one, I'll get what? X plus certain constancy. So I'll have my y sec x is equal to this as my final answer. So we have y dx plus 3x squared y is equal to x taken to the power of 5. X, yes, plus x taken to the power of 3. So here, let's find step 1. Let's find our integrating factor 1. Let's find our integrating factor r. We have r to be equal to e exponent integral of p of x dx. So per this question, I can see that my p of x will be 3x squared. Therefore, I have my r to be equal to e exponent integral of 3x squared dx. When I integrate this one, I'll get e exponent x taken to the power of 3 divided by 3. The 3 will take the 3, so we'll get this one. Then we'll take our integrating factor. So we are moving to step 2. Take our integrating factor, multiply to the original question. The original question, let me name this one equation 1. So I'll multiply this one to my equation 1. Each 10. So I'll multiply this one by r, multiply this one by r, multiply this one by r. Then I'll have something like e exponent x taken to the power of 3 dy dx plus 3x squared y e exponent x taken to the power of 3 is equal to x taken to the power of 5 e exponent x taken to the power of 3 multiplied by e exponent x taken to the power of 3. Let me rewrite this one. Then I'll have e exponent x taken to the power of 3 dy dx plus 3x squared y e exponent x taken to the power of 3 x taken to the power of 5. Indices, when the base are the same, do what we add the exponent. Then I'll have e exponent 2x taken to the power of 3. So now we'll move on to the next step. So now we'll move on to the next step. The next step of linear first order, after multiplying by your integrating factor r, multiply the whole equation or the whole function by what? Dx. So I'll multiply this one by dx. Then I'll have e exponent x taken to the power of 3 dy x dot what? X plus 3x squared y e exponent x taken to the power of 3 dx is equal to x taken to the power of 5 e exponent 2x cubed x. So we can see that this dx will take this dx. Then I'll have e exponent. I'll have e exponent x taken to the power of 3 dy plus 3x squared y e exponent x taken to the power of 3 dx is equal to x taken to the power of 5 e exponent 2x cubed dx. So we have dy dx dx. Then we have to integrate this side, integrate this side, integrate this side. Check the left hand side. Always when I see left hand side, this equation is divided into two steps. So this is the right hand side, this is the left hand side. Check the left hand side. The left complex part was what? E exponent x taking the power of 3 dy. So that's one, if we want to integrate this one will be difficult. So the less complex one will be this side. Just check this one. The less complex one will be this one. So what I will do here is that take your hand, cover the d here. What is left here is what? Y. Take the y, multiply to this side. Then I'll have y e exponent x taking the power of 3. Don't write anything again. just cancel this one. Is equal to integral of x taking the power of 5 e explain 2x taking the power of 3 what dx. So we are done with the other set. How to solve this one? But don't forget, or how to integrate this one is just a little bit tricky. But here, this one I'll just rewrite this one as x taking the power of 3 dot x taking the power of 2. When the base are the same, add the explain, get 5p, we'll get the same one back. So this one will multiply by e explain 2x taking the power of 3 dx. So I will let a certain variable, let's say, we'll have y e explain x taking the power of 3. So I will let a certain variable, let's say, u to represent x taking the power of 3. Differentiate the u with respect to x. We'll get 3x squared here, right? Then let's try to make the x the same. Then we'll get du over 3x squared is equal to what? Dx. So now my y e explain x taking the power of 3 will be equal to integral of, I have x cubed here, but don't forget let x cubed u to be equal to x cubed. So here I'll just write u dot x taking the power of 2. E explain 2u, right? Because here is x cubed. My dx is what? Du over 3x squared. So this s squared will take the s squared here. Then I'll have something like 1 over 3 here. Integral of what? U. This e explain 2u du. So I'll have my y e explain x taking the power of 3 is equal to whatever you say. Here, what you have to do here, you solve this one using multiplication by parts. So I'll have something like, so here we'll solve this one, this side. We'll solve this side. So we'll solve this one using integration by parts. So here we'll have something like my y is with the x cubed is equal to 1 over 3 out uv minus integral of v du. That's integration by parts. So here I will let just integration by parts formula. We have uv. We have variables of what u and v, but now we have u here. So just pardon me. So we just let u to be equal to u and dv to be equal to e explain 2 what? U. Differentiate du, get du. Integrate v, you get 1 over 2 e explain 2 what? U. Now let's try to push everything to the original formula. Then we'll have, you can see that e explain 2x cubed, e explain 2x cubed is common within these two terms. So we can even factor that one out. Then I'll have 12y explain x cubed out. Then I have e explain 2x cubed out. What is left here is 2x cubed minus 1 plus 1, 12c. And then even here we can just divide both sides by e explain x cubed. Then I'll have something like 12y is equal to 2x cubed minus 1 plus 12c e explain minus 2x cubed. So we'll just keep this one as our final answer. So in conclusion, anytime you are solving linear first order problem, the first thing you have to do here is check the coefficient of the dy dx. Always the coefficient of the dy dx is what? Supposed to be 1. If there's anything attached to the dy dx, try to eliminate that or try to move that one to a different location. Always the coefficient of dy dx is what? 1. And after getting your coefficient, you move to step 2. The step 2 talks about something called what? Integrating factor r, which is represented by letter of what? R. R is equal to the exponent integral of what? P of x dx. Where do we pick our P of x from? You know, after the dy dx, we will get something plus P of x multiplied by a certain variable y. So anything multiplying the variable y is a P of x. So anything that is multiplied by y is what? We'll take that one as our P of x. So take that one. So we'll have something like r is equal to e taking the power of P of x dx. Integrate your function in order to get your value of what? R. After getting the exact value of r, go back to the original question. Multiply the whole question through by what? Your integrating factor of r. Right? So after multiplying through by integrating factor, take the same function, multiply the whole thing by what? Dx. So you see that after multiplying through by dx, you will get something like dy dx. And you have to think about what? Integration. And you have to integrate each term. Integrating each term, check the left hand side. You know, I always talk about the equality is separating the two terms. What is in the left is what? The left hand side. Check the left hand side. The less complex part. You know, we have to integrate some two terms. The less complex part. Cover the D. Take that one. Cover the D. What's the level of Y? Take the Y, multiply to the function over there. Then just eliminate. Don't bother to write this other one. Just equate whatever you mean about the right hand side. In the right hand side, you have to take your time, integrate it to get your final answer. So therefore, you just manipulate you just do some rough work and get your answer. So that's the whole idea about linear first order. Thank you for watching this video.